When people think about ocean pollution, plastic is usually the first thing that comes to mind. Images of floating bottles, tangled fishing nets, and animals trapped in debris have become familiar, but those images only show part of the problem. What's happening beneath the surface and over time is far more complex and far more serious than it looks. Plastic is not just accumulating in the ocean, it is changing the structure of marine ecosystems, affecting wildlife at every level and introducing long-term risks that we are only beginning to fully understand. To see why this is happening, it helps to start with scale. Every year, millions of tons of plastic waste enter the ocean. Some of it comes directly from coastal areas, litter left on beaches, poorly managed waste, or illegal dumping. But a significant portion comes from inland sources. Rivers carry plastic from cities and towns, transporting it hundreds or even thousands of miles before it reaches the sea. Once plastic enters the ocean, it doesn't stay in one place. Ocean currents move it across vast distances. Over time, this movement concentrates plastic in certain areas, forming what are often called garbage patches. These are not solid islands of trash, but large regions where plastic debris accumulates, much of it in small, fragmented pieces. And that fragmentation is a key part of the problem. Like on land, plastic in the ocean does not biodegrade. It breaks apart into smaller and smaller pieces due to sunlight, wave action, and physical wear. These pieces become microplastics, tiny particles that are easily ingested by marine organisms. Microplastics are now found throughout the ocean, from the surface to the deepest trenches. They've been detected in plankton, fish, shellfish, and even in species that live in extreme environments far from human activity. This means plastic pollution is not limited to coastal regions. It has become a global, ocean-wide issue. At the base of the marine food web are plankton, tiny organisms that play a crucial role in the ecosystem. Some plankton species can mistake microplastics for food. When they ingest these particles, it can interfere with their ability to absorb nutrients and produce energy. Since plankton form the foundation of the food chain, any disruption at this level can have cascading effects. As you move up the food chain, the impact becomes more visible. Small fish consume microplastics directly or indirectly by eating contaminated plankton. Larger fish then eat those smaller fish. Over time, plastic accumulates within organisms, not just as physical particles, but also as carriers of chemicals. Plastic can absorb pollutants from seawater, including substances like PCBs and other industrial chemicals. When animals ingest plastic, they are exposed to these toxins. This can affect growth, reproduction, and overall health. In some cases, it can lead to reduced survival rates. Larger marine animals face additional risks. Sea turtles, for example, often mistake plastic bags for jellyfish, one of their natural food sources. When ingested, plastic can block the digestive system, leading to starvation. Seabirds have been found with stomachs full of plastic fragments, sometimes to the point where there is no room left for actual food. Entanglement is another major issue. Discarded fishing gear, often referred to as ghost gear, continues to trap and kill marine animals long after it has been lost or abandoned. Whales, dolphins, and seals can become caught in nets or lines, restricting their movement and eventually leading to injury or death. These are the most visible effects, but they are not the only ones. Plastic pollution also affects habitats. Coral reefs, which are already under stress from climate change, are particularly vulnerable. When plastic comes in contact with coral, it can cause physical damage and increase the likelihood of disease. Studies have shown that corals exposed to plastic are significantly more likely to develop infections. Seagrass beds and mangroves, which serve as important nurseries for many marine species, can also be impacted. Plastic debris can smother these habitats, block sunlight, and alter the conditions needed for growth. Over time, these changes can reduce biodiversity. Species that cannot adapt to the presence of plastic may decline, while others may be affected indirectly through changes in the food web or habitat structure. Another aspect that often goes unnoticed is how plastic affects the chemical and physical properties of the ocean itself. As plastic breaks down, it releases additives and byproducts into the water. Some of these chemicals can act as endocrine disruptors, interfering with hormonal systems in marine organisms. There is also growing evidence that microplastics can influence how carbon is transported in the ocean. Normally, plankton play a role in capturing carbon dioxide and transferring it to deeper layers of the ocean when they die. If microplastics interfere with plankton function, it could potentially affect this process, which has implications for global climate regulation. One of the challenges in addressing ocean plastic pollution is that much of it is not visible. Large debris can sometimes be collected, especially near coastlines, but microplastics are extremely difficult to remove. They are too small, too widespread, and too integrated into the ecosystem. This means that cleanup alone cannot solve the problem. Prevention is critical. Reducing the amount of plastic entering the ocean requires changes at multiple levels. At the individual level, it involves reducing reliance on single-use plastics and ensuring proper disposal of waste. While these actions may seem small, they contribute to a larger system. At the infrastructure level, improving waste management is essential. This includes better collection systems, more effective recycling processes, and measures to prevent leakage from landfills and urban areas into waterways. There is also a need for better design. Many plastic products are not designed with their end of life in mind. Creating materials that are easier to recycle or that can safely break down in natural environments could help reduce long-term accumulation. However, these solutions take time to implement, and the problem continues to grow. Another factor to consider is how long plastic remains in the ocean. Depending on the type of plastic and environmental conditions, it can persist for decades or longer. Even as it breaks down into smaller pieces, it remains part of the system. This long lifespan means that the plastic entering the ocean today will continue to have effects far into the future. It also means that the ocean is dealing with not just current pollution, but the accumulation of decades of past waste. The issue is further complicated by the fact that plastic pollution is unevenly distributed. Some regions, particularly in developing countries, face greater challenges due to limited waste management infrastructure. At the same time, ocean currents can carry plastic far from its source, making it a shared global problem. No single country or community can address it alone. From a human perspective, the impact of ocean plastic is not limited to environmental concerns. It also affects economies and livelihoods. Fisheries can be impacted by declining fish populations and contaminated catches. Tourism can suffer when beaches and coastal areas are polluted. There are also potential health implications. As microplastics enter the food chain, they can eventually reach humans through seafood consumption. While research is ongoing, the presence of microplastics in food and water raises important questions about long-term exposure. Despite the scale of the problem, it's important to recognize that it is not irreversible. The ocean has a remarkable capacity to recover if pressures are reduced, but that recovery depends on reducing the flow of plastic into the environment. This requires coordinated efforts across industries, governments, and communities. Policies that limit certain types of plastic, incentives for sustainable alternatives, and investments in waste management can all play a role. At the same time, continued research is essential. Understanding how plastic behaves in marine environments, how it affects different species, and how it interacts with other environmental factors will help guide more effective solutions. Ultimately, the issue of plastic in the ocean is not just about waste. It's about how materials are designed, used, and managed. It's about recognizing that the consequences of those decisions extend far beyond their initial use. The ocean is not a closed system where problems stay contained. It is interconnected with the atmosphere, the land, and all forms of life. When plastic enters the ocean, it becomes part of that system. And once it's there, it doesn't simply go away. It moves, breaks down, accumulates, and continues to affect the environment in ways that are often difficult to see but impossible to ignore. Understanding this is the first step towards addressing it.